All right, guys, as promised, here's that question from last year's HSC. I think this is question 12B. If you want to go have a look at the solutions, it's somewhere in question 12. Was out of 3 marks, and last year we did not perform particularly well in this. First couple really shouldn't be too bad though, so let's see what we can get here. We've got a coin that's being tossed 100 times. It's biased, so its probability of heads. Its probability of heads is 3/5. Which means we can also say probability of not getting heads is 2/5. So it's complement. So this is going to be our proportion and our complementary proportion as well. So our expected value here, treating this as 100 Bernoullis, is going to be 3/5 times 100, which is 60. We're expecting 60 heads. By finding the variance, show that the standard deviation is approximately 5. To find our variance here, we're going to use P multiplied by Q, which is 1 minus P, and we're going to multiply that by our number of trials. Now, we've already done NP here in part 1, which is 100 times 3/5, which is 60, so we can substitute that in. Or I actually like the visual of saying it's 3/5 multiplied by 2/5 multiplied by 100. Now that gives us 24. So our standard deviation is going to be the root of 24, which is about 4.8. And then we're asked to show that it's approximately equal to 5, which it is. Part 3 here, we're asked to use a normal approximation. Now we've got our 2 boundaries there. Now we need to turn those boundaries into proportions. So our P lower, our lower proportion is going to be 55 out of 100, or 55%. Our upper proportion is going to be 65%. And our mean is 3/5, which is 60%. And we found our standard deviation, and we nicely approximated that to be 5%. Now you've shown that it's approximately 5% in the previous question, so you can use the rounded version, which is okay. And in fact, this was an HSC question where you were not given a table, so you needed to have nice values, advanced type values, even standard type values that could fit in nicely onto our empirical rule. Now what we find here is that our Z scores, our Z lower, L for lower, is going to be our score, our score of 55 minus our mean of 60 over 5. They're all percentages, so I don't need to worry about the percentage symbol. So that's -1. And our upper Z score, again, really nicely, is 65 minus 60 over 5, which is +1. So we're asked to find what percentage of scores lie between a Z score of -1 and +1. Well, we can straight away say that that is going to be a nice answer, a nice empirical rule question of 68%. So therefore we can finish it up by saying probability that we lie between 55, or probability that X lies between 55 and 65 is going to be 68%. If it was numbers that were not quite as nice, we would need to have a table, but because the numbers are nice, we don't need a table here.